Dear students, in today's lecture we are going to study circles. Well, circles in this part are not very descriptive. They are based on the theorems, and then you can solve the questions depending upon these theorems. So first of all, we'll see what a tangent of a circle is. First of all, the locus of all the points drawn from a fixed point at a fixed distance is known as circle. This fixed point will be the center of the circle. This fixed distance will be the radius of the circle, and the locus of all the points, locus means the arc formed between the 2 points. If I join the locus of all the points, this will give me a circle. Now we have been studying chord. Chord is a line segment that join any 2 points on the circumference of a circle. But chord never comes out of a circle, it always stays inside. Now if a line segment that can intersect at 2 points in a circle and can exist outside the circle, this will be secant of the circle. Then another line which touches the circle only and only at 1 point, tangent touches the circle only at 1 point, will be known as tangent. And this tangent at the point of contact, this is the point of contact, will always be 90 degree from the center, right? So first of all, tangent, again tangent is a line that touches the circle at a common point, and this common point is always 90 degree at the radius. So it subtends 90 degree at the point of contact whenever it is joined with the radius. So wherever it may lie, the angle with the radius will be 90 degrees. So there are some theorems based on this. First of all, tangent is perpendicular to the point of contact from the center of the circle. So it is always 90 degree from the center of the circle. At max, 2 parallel tangents can be drawn to a circle. Of course, you can draw infinite tangents to a circle because circle is made up of infinite number of points, but at a given point there can only be a single pair or 2 tangents that can be drawn parallel to each other, like this or like this or even like this or like this. But at max, the total number of parallel tangents that you can draw is only 2. So only 2 parallel tangents can be drawn to a circle. Infinite tangents can be drawn to a circle. Tangents drawn from the external point are equal. Now this is tangent PB and this is tangent PA. They are drawn from an external point P, so hence PA will be equal to PB. We'll prove it later on. And the angle between the 2 tangents, this is the angle between the 2 tangents, and the angle subtended at the center. So this is the angle subtended at the center. So these 2 angles will be supplementary. So angle APB plus angle AOB should be 180 degrees. So angle between 2 tangents drawn from an external point to a circle is supplementary to the angles subtended by the line segment joining the points of contact at the center. Center पे जो angle बन रहा है उसे 90 डिग्री होना चाहिए. तो एक बार इसको देखते हैं, और इसमें यही वाला हमारे पास एक मेन प्रूफ है, इसको करते हैं उसके बाद फिर देखेंगे. Right. So these are the crucial points which will help you in proving the questions. Then meanwhile, since this is a very regular question, we'll first of all start proving this. With this same diagram, we can also prove that PA is equal to PB, and we can also prove that these angles are supplementary. So first of all, I'll write in triangle PAO and triangle PBO. So these are 2 triangles that I have taken, right? So AO is equal to OB, the radii of a circle. Then PO is equal to OP, this is common. And we know that tangent forms 90 degree at the point of contact from the center. So angle PAO is equal to angle PBO both 90 degrees. So I'll write triangle PAO is congruent to triangle PBO by, this is R, this is H, and this is S. So by RHS rule. So right hand and side. So with this I can say that PA is equal to PB by CPCT, that is congruent parts of the congruent triangles. So PA is equal to PB, hence tangents drawn from the external point are equal in length. So tangents drawn from external point are equal. Hence you can also write that this angle will be equal to this angle because it lies in this triangle. This is angle 1, this is angle 2, this is angle 3, and this is angle 4. So angle 1 will be equal to angle 2 and angle 3 also equal to angle 4 by CPCT again. So you can also prove one more theorem over there, that the angle formed between the tangents are equal at the center. So angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Then the last part. Now since PAOB forms a quadrilateral, so I can say that angle P plus angle A plus angle O plus angle B should be 360 degree. This is angle sum property. Now angle A and angle B both are 90 degree because tangents are 90 degree at the point of contact. So angle P plus angle O plus angle A is 90, angle B is 90, this is 360 degrees. Now angle P plus angle O becomes 180 degrees. So hence, last thing, that the angles subtended by the tangents and by the center are supplementary. So angle O and angle P are supplementary angles. Right. So with this we conclude both circles. In next videos we will be discussing more about the other chapters. I hope you have understood all the proof. Just by one figure you can prove 3 questions from here. Just by making these triangles congruent you can prove the tangents are equal. You can prove that whole angle let's say 5 plus angle 6 is 180 degree, and you can also prove that the angle between the tangents are equal. Angle 1 is equal to angle 2, and even the angle, the tangent subtended in the center, that is angle 3, is equal to angle 4. They are also equal. I hope you have understood it. For more videos, please subscribe to our channel and like our videos. Thank you.